Determine the first 5 terms of the sequence if f of 0 equals 5 and f of n equals f of the quantity n minus 1 times negative 3. To begin, we are given f of 0 equals 5, and now we use the function rule to determine f of 1. Notice when determining f of 1, n is equal to 1, which indicates f of 1 equals f of the quantity 1 minus 1 times negative 3. Simplifying, 1 minus 1 is 0. F of 1 equals f of 0, the previous term, times negative 3. F of 0 equals 5, which indicates f of 1 equals 5 times negative 3, which is negative 15. Notice to determine f of 1, we multiply the previous term by negative 3. This will be true for the remaining function values as well. To determine f of 2, we multiply f of 1, the previous term of negative 15, by negative 3, which is positive 45. But let's also show the work using the function rule. When determining f of 2, n is equal to 2, f of 2 is equal to f of the quantity 2 minus 1 times negative 3. Simplifying, f of 2 equals f of 1 times negative 3. And again, f of 1 is the previous term of negative 15. F of 1 times negative 3 is negative 15 times negative 3, which is positive 45. Continuing this pattern, f of 3 is going to be equal to f of 2 times negative 3, which is 45 times negative 3, or negative 135. But again, let's keep showing the work. When determining f of 3, n is now 3. F of 3 equals f of the quantity 3 minus 1 times negative 3. Simplifying, f of 3 equals f of 2 times negative 3, which is 45 times negative 3, which equals negative 135. And now let's determine the fifth term in the sequence, which is f of 4. When determining f of 4, n is 4. F of 4 is equal to f of the quantity 4 minus 1 times negative 3. Simplifying, we have f of 3 times negative 3. And of course, the pattern continues. F of 3 is the previous term of negative 135, which indicates f of 4 equals negative 135 times negative 3, which is positive 405. And now we have the first 5 terms of the sequence. Let's give the sequences a list. We have 1, 2, 3, 4, 5 terms, where the first term is 5, the second term is negative 15, the third term is 45, the fourth term is negative 135, and the fifth term is 405. And of course, the sequence could continue. You may recognize this as a geometric sequence. We have a pattern of multiplication. Notice 5 times negative 3 is negative 15. Negative 15 times negative 3 is 45, and so on. And we can see the multiplying by negative 3 in the function rule for f of n. And because we have a geometric sequence, we can also determine the common ratio r, which is negative 3, by taking any term in the sequence and dividing by the previous term. Notice negative 15 divided by 5 is negative 3. 45 divided by negative 15 is negative 3, as well, and so on. I hope you found this helpful.